are of the white students are not taking any Algebra 2. Now, why do you think that might be? Is that because the white students are probably underserved and so they're not taking any math at all?
Maybe they've completed their college entrance requirements already.
Exactly. So when we look at data, this is again what this is data about your students, right? And so they can look at this and they can draw conclusions. And this is exactly what education equity people are doing right now as they debate whether or not it should be required to take a fourth-year math course or not. So they're looking at these discrepancies, but if you just look at them without the context, you might say, oh, well, look, we've got only 49% of white students are taking a fourth-year math class. Well, guess what? That's because they took AP, AB calculus as juniors, right? So there's no question that the white community is being very well served. What we need to worry about is the majority of students, Latino or the African-American students, who seem to be underrepresented in the fourth-year math classes and overrepresented in the repeating Algebra 1, Geometry, and Algebra 2. So if we're going to draw conclusions for data, we don't just need to have the skills to see the differences, but we also have to be able to contextualize them. So now if we go on to what we just worked through, which was the answers to those questions, so we've already done that. Here's the full solutions, and I'll post these slides for you. When we get to the last question on lesson 2 on unit 1, it's now we have a more complicated question, and we ask, hey, are these two groups homogeneous? So we've got people who mainly use the landline.
Kate, we can't see it again.
Hello, it's not clear again.
Okay, and also my audio is terrible. Ottilia, I'm gonna log out and log back in.
Okay.
So hang in there.
Okay.
I don't want to kill it for everybody else, because also my audio has gone completely nuts.
Okay, so go ahead, restart, and we'll be here, and I'll make you host again.
Okay. It's not letting me leave without ending the meeting for everybody. So I think you have to unmake me a host.
Okay. Hold on.
Or maybe I am the host and I have to hand it back to you.
Yes, you do.
Okay. So while I'm off, I'd like you to think about in that chart that I was just sharing with you, what would you have to do in order to decide that the two groups were homogeneous, given that you've got way too much information? How would you even go about doing that? So while I'm off trying to recover myself in the universe, that's what I want you guys to be thinking about doing. And right now, Ottilia,
and we can find that in the Jamboard, Kate?
Yes. So Ottilia, do you want to share with them that Jamboard for the, oh no, it should have been in the Jamboard, but no, because I was going to just do this as a whole group discussion. Okay, hang on, I can put it in the Jamboard. Let me go over there. Okay. Almost there. So if you're looking at me on the Jamboard, I'm on page 1 of the Jamboard. And what I'm going to do is on the top of that Jamboard, you'll see that there was a little icon that was all of the slides are actually in that icon. And what I just did was I pulled out question number 6. So now if you go to page 1 of the Jamboard, you'll see that question. Okay. So what am I going to do?
Yes, we can see it.
Okay. All right. I'm changing host, and then I'm going to leave and come back.
Okay.
I'm back.
Okay.
So let me share the Jamboard because that seems to work better for now. So boom, boom. Okay, so there's the Jamboard. So what you see is we just have the raw data, right? So we don't have the percentages, we don't have them broken down, we don't have them as a bar graph. And we can ask whether or not these two groups are homogeneous with respect to whether or not they use, if the various groups, whether or not they principally use a landline or whether they use the cell phone, whether the four groups there are homogeneous. Now, first of all, the thing to notice is the data in this case is reversed, right? Because the categories are the ages, which are on the vertical, and the question is landline versus cell, all right? But the other thing is there's just a lot of information. So we could convert all of these into percentages and it would still be pretty difficult to identify whether or not this is a homogeneous group. So we need a couple of things. The first thing we need to do is to understand what it might mean to say that these groups are homogeneous and that the outcome that we see as represented by those numbers above, that outcome would have been likely to happen by chance. And what that means is that if we had, if those groups were perfectly homogeneous and we pulled a sample out of those groups of those numbers, namely 46 18 to 29-year-olds, 70 30 to 49-year-olds, 45 50 to 64-year-olds, and 35 65 and olders, would we be likely, sorry, that wasn't the totals, that was only the cell phone. So if you added up how many you had in each of those rows and you pulled out that many people, would this outcome be likely just to happen by chance? So what exercise have you done so far that's representative of that kind of a question? That's comparing an actual instance to something that would happen by chance if we assume that everything were just random.
The homework assignment?
Where?
Yeah, which homework assignment?
One where we had to pull the different ages several times.
Exactly. So that's where I'm going to go now. I want to pull up the actual data that you guys collected for that exercise. And I think that's as far as we're going to get. So I'm going to stop sharing and I'm going to try sharing exactly your data. So let me find that. So I'm going to pull that up and then I'll share that. Supplement B, yeah, here it is. So let me share that with you. Here we go, boom, desktop 2, okay. So can you see that?
Yes.
Okay, so what you're seeing here is everybody who answered the question by about, what time were we working on this, Otilia, last night? Around 10:30 or 11?
10:30, yeah.
So here we have everybody who participated by that point, and we just copied your data in. And so you ran the experiment just as though it was random, right? So the important thing to get across to students is there's an actual instance, which was that company fired, how many people did they fire? 14 people? Or were there 14 people?
Yes.
Okay. Or was it 14 employees overall? I can't remember.
They fired 10 out of 14.
Thank you, Greg. So they fired 10 of their 14 people. That is an actual instance, right? So the statistic that we pulled out of that actual instance was what?
How many people were older
Than
40?
40, very good. So that was an actual instance. And then what we did was we ran random trials that modeled what would happen if that same action, firing 10 of 14 people, were done randomly. And what that allows us to do is to compare the actual situation, the one that actually happened, to the one that we're simulating with a random event. And so we took all of your 10, the people who responded, so it looks like we got 110 people, so that was 11 people that participated, and I put all of your statistics into a histogram, okay? And then what I computed up here was, this was the different totals. So the total, all of these values, all of the statistics that you came up with, what was the statistic again? So somebody who turned it in, what was your statistic, so for example, Patricia got a statistic of 7. What does that statistic mean?
7 of those 10 people pulled were older than 40 years old.
Great, and then she did it again, and it was 8, and then she did it again, and she got 8 again. And so where is this these 2 8s? Where are these 2 8s in my histogram?
On the right-hand side of the 8.
There we go. So they're one of the things pushing this bar up. Now, you may feel that I'm talking down to you right now, but if you are not going through those details with your students, they are not understanding, I guarantee it. Because people do not understand the relationship between a list of numbers and a histogram in general, okay? So the height of this histogram here, between 8 and 9, is how many 8s appear in this list, right? Which you know because you did that exercise, right? So that physical exercise of building and putting those dots in, so don't jump to the Google sheet right away. Having the students put those dots in so that they feel what the histogram is really essential, okay? Now we've accumulated all those dots, all 110 dots, and we notice that 91 of them are bigger than 5, 52 of them are bigger than 6, 17 of them are bigger than 7, 1 of them is bigger than 8, and none of them are any bigger than 9, right? They couldn't be bigger than 10 because we only fired 10 people, right? And so we end up with this histogram where there's nothing below 5 and there's nothing above 9, right? So there was no instance in which all 10 of them were over 40, right? I see Mercy is holding her head. Actually, lots of people are holding their heads now. All right. So now what can I conclude from this? I'm not asking you to come up with a chi-square right now. What I'm asking you to come up with is what would be sensible? At what point would you be a little bit suspicious about the number of people over 40 that were fired? So in the actual event, how many people over 40 were there that were fired?
10.
There were 10 people fired. How many of them were over 40?
Oh,
7, I think.
7.
7.
yeah.
So would you say the outcome of having 7 people over 40 was an unusual outcome if it were done at random?
No.
No, it's actually our second highest bar, right? Right?
Yes.
And if I look at the number of trials in which it was over 7, you know, it's still a lot, right? So it would be this whole bar plus this whole bar plus this whole bar, right? So this would be a big chunk that were over 7, okay? So
Hey, I have a comment.
yeah, please.
When I was doing doing my own data and it was out of 10, I had like majority 6 like that in there, and then it was a 7, like 3 out of 10. Really, that was 7. With the more than. Oh, yeah. So I was saying that when I was doing my data, I had like my probability was 3 out of 10. That's what I was saying.
Your probability of what?
When I did with just 10 employees, right? If I was doing with the 10 cards, so my majority was really 6, and it was like all 6s, and then 3 of them were 7 or 8, like that.
Oh, okay. All right.
So I'm saying that my probability for my own data was 3 out of 10. So I would have concluded on my own that it's just not a lot. But when I see it in this with a lot more data in here, then it really is showing a more likely, you know, it is definitely showing that it's a lot of 6s for sure. That's the highest.
Right.
But if I continued the data, it probably would have shown that 7 would be the second greatest in there.
Exactly, exactly. And so, of course, it depends on the context where we would put that threshold, right? Like how unusual is unusual enough to be suspicious? And in general, in statistics, can anybody remember what the threshold is? If something happens less than what % of the time, then we start thinking there's something fishy going on, that it wasn't random. What is that threshold?
5%.
5%, exactly. It's pretty low, okay? So just because something happens, say 25% of the time, doesn't mean it would be unusual when you do one sample, right? That would be 1 out of 4. So that, you know, if somebody tells you you have a 1 in 4 chance of dying when you cross the street, you're gonna be like, oh, maybe I won't cross the street. It's not an unusual or an unlikely event, right? So when we're thinking statistically, we're going to compare our actual outcome to how likely that would be to happen if it were done by random draw. And we're going to start being suspicious if our outcome would happen less than 5% of the time, which is certainly not the case here, right? We can see that we've got this happening way more than 5% of the time. Does that make sense? Okay.
So, Kate, just to clarify, let's say we got for something greater than, let's say, I guess I'm trying to connect the idea that you said about if it was greater than 5%, and obviously ours is, right? Because ours is 16%.
So actually ours is 47%. It's just I don't have a greater than or equal to, right? So if it's greater than 6, 47% of them were greater than 6. 47% of the results were 7, 8, 9, or 10, right? So that's the number that we're interested in. If our event falls in the area that would happen only 5% of the time. So that's the number. So statisticians wouldn't even be suspicious if we got an 8. Statisticians would start being suspicious if we got a 9. This is the part of the histogram where they would start saying, this is really a pretty unlikely event. Does that make sense? So here I can rename maybe it's better if I rename this. This is greater than or equal to 5, right? And this one is greater than or equal to 6. And this one is greater than or equal to 7. I just don't know how to do that. So really our case falls into what happens 47% of the time. In other words, this part of the histogram, the 7s, the 8s, and the 9s make up almost half of all possible outcomes. So our outcome is falling into the region which is basically half of what happens.
But if that was less than 5, then we would say, okay, no.
Yeah, if I were, exactly. Yeah, if that were less than 5%, so if I'm over here, then I'm starting to get suspicious. Does that make sense?
Okay, yeah.
Yeah, so if I got a value that were, I'm not sure if I've got those numbers right. Now this should have been greater than or equal to 5, 6, 7. I think I messed up my numbers again. Anyway, this is greater than or equal to, this should have been 7. This should be 8. I can do I know numbers. This is 9. There we go. And this is 10. Okay.
So how would the bar graph would look like if to be suspicious? Let's see that.
So if your specific outcome had fallen in this part of my bar graph, then I would start being suspicious. But I could add fictitious data to this bar graph. Like I could start adding, I don't know, maybe I'll copy a whole bunch more 6s. Or maybe I'll copy a whole bunch more 5s. So I'm going to put them.
Kate, we're already at 12.
Ah, okay, thanks. So you see how that changes my bar graph? It squishes it down. So I've added a lot more weight over here. So now we need to reconfigure these computations. But you see how that changed the percentages? So we're gonna have to stop now. So what I'm
Well, this is important.
I know it's important, but I just want to, I want to acknowledge what the people who are coming back to the room. So let me make this go up to, say, 200. 200. So you'll see what the bar graph starts shifting to be. So you see how that's shifting down, and now I have only 10% of the time I'm greater than or equal to 8. If I keep doing that and I throw in a bunch more, let's put in some 4s now, and then I'll wrap up, and those who want to stay can stay. So we'll do a 4. Copy and then paste. Let's see what happened to our bar graph now. So you see how it's flattening out over here? I'm still not able to get, I'm trying to force this to go down below 5%. But suppose our threshold were 10%, then we would start saying, oh, anything greater than or equal to 8, that's starting to be suspicious. So if our statistic hung out there, you see what I'm saying?
Yeah.
Okay. But you're absolutely right. This is really important. And it's one of the things that somehow when we take statistics, nobody ever explains to us. It's kind of interesting. So what I'll do, since we didn't get to the M&Ms, I will do the M&Ms next time, and maybe I'll create another video sort of running through this data, and I'll share it with you through I have a YouTube playlist for this group. And I'll share that video, and then we can pick up from here. But I think now you're really ready to start thinking about the chi-square, because the chi-square tells you, given this situation, this is where the 5% threshold is. This is where if you have 6 categories of objects and they're supposed to meet a certain criteria, if you had a random draw and you get the chi-square, that chi-square statistic falls either above the 5% or below the 5%. So you know whether or not you're comparing, when you compare to the random situation with those expected values, how unlikely or likely your chi-square statistic is. So that's the goal of the M&Ms. And then people are going to be able to do the homogeneity test, which is what the book does. So I'm going to be respectful of your time, at least semi-respectful of your time. So I am going to stop here. I want to make sure that you have the information you need. So Otelia and I will stick around to answer questions. But that is the end of the presentation today. I want to make sure that you sign out. So we're going to put into the chat one more time that Google Sheet for the sign out, which is probably already there. In fact, there it is. So be sure to sign out. And the other thing is we will be sending you a follow-up email again. That email will include the link for you to let me know about issues that you're concerned about, whether it's signing on to Schoology or getting your textbook. So I would ask that you don't email separately, that you fill out that Google Sheet first, so that I can send your district one email with all the people who have a common problem. Because I find that districts are much more responsive if I write to them rather than you, and if I write to them once with all the names, so then they can take care of the issues. Whereas if I have to do it piecemeal, they stop listening to me after a little bit. And if you ask, sometimes that's less effective. So let me do that. We're not going to put it into the chat right now because I don't want to confuse you with the link for the attendance that you need to close down. If you'd like to stick around, my priority is going to be making sure that everybody here is able to get onto Schoology and able to get into the TCMS group and able to receive messages from the TCMS group, able to get into the TCMS PD class and turn in their work. You have an assignment for the second 3 hours of today to make today another full PD day. But I think we've all had enough Zooming for one day. And I look forward to our next meeting in August, where we will do the M&M experiment. And I may send you a little pre-work on that, so you can get warmed up for it. And then I will let you know as we develop other resources like the quizzes and the tests for Unit 1. The ALEX template for your courses will be available closer to the time that your classes exist. Because of the single sign-on, we can't create the courses until the MISIS does its job on the LAUSD side. For Compton, we may be able to get you up and running a little earlier. Okay, so if you have no questions, then feel free to go and enjoy the rest of your day and get on with your homework. I thank you for your patience, your hard work, your diligence, your participation. I think I'm very lucky to have the opportunity to work with you. And when I go into those breakout rooms, I'm just stunned by the quality of the work that you do. And it's so obvious that you're all really engaged and excellent teachers. And I wish you the same from your students, that your students will participate with the same vigor and the same enthusiasm, the same grace, the same kindness, the same intellectual challenge that I see in all of you. So thank you for that. It's really a privilege to work with all of you.
A question for you.
Yes, Mercy.
I emailed you my assignment. I emailed you my assignment. Can I still?
You can still. I deliberately made the due date until 11:59 today. So I'm happy to ignore your email.
Yeah, that's for yesterday's assignment.
Yeah, so yesterday, the stuff that was due yesterday or today, the actual time, if you look at the due date, it's 11:59 today.
Okay, so I can still upload that.
Absolutely.
Okay. All right. Thank you.
Wonderful to meet you.
Wonderful to meet you too. Thank you so much.
Yes, welcome Almonte.
Thank you.
Okay.
Bye, Celia.
Can we get our book,
Hi, colleagues.
the real book?
Hi. Is that who's speaking? Oh, hi. So again, if you could fill out that Google sheet, which you'll get in your email today, then
Yeah, I filled it out.
Oh, good. So I'm going to send that list to Amy to try and see if I can get all the new LAUSD teachers, your textbooks, your teacher editions, before you all disappear for the summer, so that you have it, the hard copy. But as a backup, if you remember, let me stop sharing that and share, go back to share my desktop. Share.
I don't have a book.
Yeah, I know, but you remember on the Schoology site, so let me.
Materials?
Yes, that was the thing that I didn't want to.
I saw it already. So
Yeah.
I'm just curious for the real book.
So I will try and get to everybody the textbook as soon as humanly possible. But in the meantime, can you see on my screen these two PDFs? Those PDFs?
Yes.
So they're not great, but they're the best I can do. And then as soon as you are a teacher in the class in LAUSD, you have access to all of the TCMS resources. And then I am working with Amy Wishima to make sure that the LAUSD teachers that you get, the new teachers get your teacher's edition as soon as possible.
Okay,
and what I told them was by the end of next week.
Okay, sounds great.
Yeah, hopefully that's true. With El Monte, they're just in the middle of signing a small avalanche of paperwork. I've never dealt with a district that's more cautious about their indemnity. But as soon as that's done, they'll be able to spend some money on textbooks, and you should have your textbooks shortly. And for Compton, y'all should have your textbooks because you already taught this class once.
But I need the teacher edition.
You never got the teacher edition?
No.
Excellent. So Aka, did you fill out that Google survey to let me know that?
I will send you that information.
No, don't email it to me. Fill out the survey that you'll get in your email. So we're going to send you a follow-up email with your homework assignments for the, it's not homework, right? It's just to make sure that you get a little more of a full day of PD. So the inside of that email will be a link to a survey where you can tell me your name, your email, your district, your high school, and exactly what you're missing. And that way I can just send one message to Amy, and she's more, or to actually in your case, Ray Jeanette, to make sure that she gets you the resources that you need.
So where will it be? In an email today or?
It will be an email today to you from Otilia.
Okay. And one last question. You know,
Okay.
earlier on today when you were speaking, you said something like that when you were talking about Alex, you said that it's only relevant if you are in LAUSD.
That was
So
the
what
single.
does that,
Alex is relevant for you. What I said was the single sign-on is only relevant if you're at LAUSD.
okay, okay.
If you're at Compton or El Monte, we need to purchase the Alex codes separately. If you're in El Monte, it looks like they're not going to get you the codes, that they're going to let you figure out the TCMS this year, and then next year they'll get the codes, because El Monte, you're not teaching the class this year, you're just learning how, you're just attending the PDs. So
Okay.
the El Monte is not going to do the Alex part, whereas Compton, as far as I know, is going to provide the Alex codes.
Okay, that's good.
And maybe the same thing is happening into our school also, because we are the first one to send to this training, and we don't have the textbooks, we don't have anything. I mean, and I don't know if it's going to be part of the curriculum for next school year.
Yeah, so that's tricky. In LAUSD, they're a little fussy about purchasing textbooks if you're not actually teaching the class. So if they come back to me and say that we can't get you a textbook because you're not teaching the class this year, I may see if I can ask my funder. We are supported by 2 separate grants, and I might be able to use that grant money to purchase textbooks for people whose district is not willing to purchase them. But technically, the district is supposed to agree to purchase them.
Thank you.
But I know LAUSD is a little, they're a little stricter about even allowing, they don't even want people to come to the PD if they're not actually teaching the class. And I keep arguing that it's great if people come to the PD before they teach the class, because this class is such a